welcome back, guys. So in part 1 we just introduced the definition of a finite automata and the language, and then we saw what do we mean we saw the types of finite state machine and how we represent it. Now here we have our first type that has no an output, which is a deterministic finite automata. Now, a deterministic finite automata or a deterministic finite acceptor is a quantable, which is a machine with 5 tuples. Those tuples are Q, sigma, Q naught, del, and F. Alright, Q is a non-empty set of state, and we usually represent this by transition diagram, a circle with the title of the state. Sigma is an input alphabet, which is a number of symbols that can be numbers, 0s and 1, and can be letters, which is A, B, and so on. Alright, and it comes something like this. Alright, Q naught, which is the initial state or the start state. It is one of these sets that comes in Q. Not basically should be Q naught, but all the time or almost it comes as Q naught. How we represent this in a transition diagram? By having the following arrow. Then we go to del, which is a state transition function, where we have an input that comes in a state and take me to the next state. And here is the concept of deterministic. Now, a determinism in a finite automata is when I have an assurance that I will go to the next state. So having an input on a current state should take me for sure to one unique next state, no an empty state. Keep this note in your mind. We will repeat it in our next type. How we represent this? We represent it using an arrow with the sigma here, the alphabet or the symbol. Now if I put 1 or I entered 1 in Q0, it will take me to next state, which is Q1. So here we just finished with the 4 tuples. We left with 1, which is F, and F is a final state or the accepting state. And we're representing using the diagram's transition by having 2 arrows in a state. Alright, now let's move to an example. Let's suppose we have here a machine M that has Q naught, Q1, Q2, 0 and 1, Q naught, del, and Q2. So what do we mean by this? First of all, the number of states that I have here, they are 3, which are Q0, Q1, Q2. Sigma is 0 and 1. Initial state is Q naught, and final state is Q2. Now my del, which is my transition function, represented as you can see in here. So we can convert the rule in here to a transition table. We put on the leftmost the states that we have in our machine, and on the topmost 0s and 1. Now if 0 comes in Q naught, if we can see here, if 0 just entered in Q0, it will take me to Q1. If 1, then I will remain in the same state. Moving to next state, which is Q1. If 0 was an input in Q1, then we will go to Q2. If 1, then we will go again for Q2. For the last state, which is Q2, if 0 is entered, then we'll go to Q0. If 2, then we'll go to Q1. So what we did here is we translate our transition function del to a transition table. Now we need to translate those transition table to a transition diagram or a directed graph. So my information was this. I have 3 states, 2 inputs, initial state Q0, final state Q2, and the del represented in my transition table here. So what can we do now? First, we draw the states by having a circle and the name of a state inside it. Then we need to initiate where the machine will start, which is Q0, and we go one by one. So if 0 enters to Q0, then it will go to Q1. If 1, it will remain in its place. If 0 goes to Q1, then it will go to Q2. If 1, it will go to Q2. So I can have one arrow with 2 inputs here. And for Q2, if 0, it will go to Q0, and if 1, it will go to Q1. And here we just draw our machine and how it reacts to each input. We forgot one thing, which is the final state that can be drawn as 2 circles. And here is the accepting state. Yeah? All right. Now let's see another example. We have a machine with 4 states, 2 symbols as an input, initial, and 2 final state. And here the del is from beginning as a transition table. Now what do we need? We need just to draw a state diagram of machine M and check whether the strings ABA, BBAB are accepted by machine M. So first of all, to draw a state, we just need to represent whatever we said in here. Our example here is describing a machine with 4 states, 2 inputs, initial state, 2 final state, and the del represented in our transition table here. What we need to do is we draw a diagram or the state diagram of machine M, and then we check those 2 strings if they are accepted by machine M or not. So to draw the state diagram, first of all, we need to represent each state with a circle and its name. Then we go for the initial state, which is Q0, and the final state, which are Q1 and Q2. Now let's move to if those inputs goes inside a state, what the machine will do. So if A is if A comes to state 0, Q0, it will remain in its place. If B, it will go to Q1. For Q1, A will go to Q0 and B will go to Q2. For Q2, A will go to Q0 and B will go to Q3. And for Q3, for A and B, it will remain in itself. And that's it. Here we draw the state diagram of a machine M. Now, let's check whether ABA and BBAB are accepted by machine M. And how we do so? We just take a string and check when it goes inside the machine how it changed the status. And we will see where it is accepted and where it's not. So starting with the first string, which is ABA, we start initially with Q0. Now A is entered to Q0, so it will go to Q0. Then B, it will go to Q1. Then A, it will goes to Q0. And if you notice here, it doesn't reach the accepting state or the final state. That's why ABA is not accepted by machine M. Let's check the second string. BBAB, starting with the initial state. If B goes to Q0, we will go to Q1. Then B, Q2. Then A, Q0. And finally B, Q1. And here we reach the final state or accepting state. That's why BBAB is accepted by machine M.